In the last few years, I've seen a ton of videos that are trying to get you to make that commitment to learn to code. You'll see the big guys in tech like, we'll say Bill Gates, Mark Zuckerberg, Jack Dorsey. All of these guys will get on camera and will talk about how code is the future and how everyone needs to learn how to code. Well, this is generally a good statement, I think. There are definitely some considerations that you want to make as you're deciding whether or not you want to make that jump and make the time commitment to actually learn how to program. This isn't something that you're going to do over a weekend or even over a couple of weeks. This is a very large commitment to teaching yourself how to basically speak the language of computers. And with that, you'll probably have a few doubts of whether you're, the right person for that, whether your skill set and your personality is going to be a good fit for this thing that we call programming. In this video, not only am I going to address that main question of, do you need math? Do you need a competency in math in order to be a good software engineer? But also to understand things like, do all disciplines within software engineering require math? Are you at an advantage if you took, calculus, 4 or something like that in school? And furthermore, we'll, at the end of the video, I'm going to kind of address the question I think you're really here for. So stick around for that. Before I get into this video, I want to address my own experience because there comes biases with experience, and that's going to reflect on my answers to the question. I am a full stack software engineer, which basically means that I program the web. And what that might entail is something like a web app, browser plugin, APIs, and pretty much anything that relates to your experience when you open your web browser. Secondly, I will say that I did enjoy math when I took it in college. I took up to Calculus 2, which, I wasn't any superstar or anything, but I was good enough, I understood it pretty well, and I generally enjoyed it. I generally enjoyed the problem-solving aspect of it. So these two things are definitely going to inform my answer, but just keep them in mind as we're talking about this subject. So to answer that first question of do all types of programming require math? I think that this is a very difficult question to answer because everyone is going to define programming a little bit differently and the disciplines within it. For that reason, I want to lay out a little bit of a table that is going to help us think about this better. I've broken out software engineering into 5 categories. So you have front-end development, back-end development, you've got the machine learning, AI, and data science category, you have Devops, and then you have a testing engineer. Before you jump to any conclusions looking at this table, I want to clarify something. I want to make a generalization that will help us think about this a little bit better. So the generalization is this: programming and math both require problem solving, but programming does not usually require math. And furthermore, whether your programming discipline requires math is highly dependent on what you are actually trying to build. Well, it came out of my mouth a few seconds ago, I really don't like the phrase problem solving. It doesn't mean a lot to me, it's overused, and therefore I think we should have a definition of it. So in my opinion, I think problem solving is the following. Number 1, problem solving is taking a problem that you know nothing about and you have no clue where to find the answer to, and being able to take that problem and somehow figure it out. If you're good at using Google, I think you're fine in this category. Number 2, being persistent enough to take on a problem that's been nagging at you for 1 or 2 or even 3 days, doesn't seem possible to solve, but still persisting and continuing to try to solve it, even if it may be impossible to solve. And with that comes caveats, obviously. You're not smart by dragging on a problem that's completely trivial to what you're trying to do. I'm more talking about those problems that are complete roadblocks in your path to, achieving the goal that you're trying to achieve. And finally, 3, the ability to think about a problem in multiple different ways, because in programming and in math and a bunch of other disciplines, being able to do this is very helpful, as the first way of solving a problem is usually not the most straightforward. Your definition of problem solving might be a little bit different than mine, but I think this is a huge requirement in both math and programming, and therefore I wanted to get that definition out there. Generally, you've got to be a good problem solver to be a programmer, but let's jump into the individual disciplines and see kind of what each of them entail. We'll start with front-end development, which is basically anything related to your experience on the web. It's what, the front-end engineer is someone who decides what happens when you click a button on a website or you submit a login form, stuff like that. The front-end engineer is going to design your user experience. A front-end dev is usually going to use HTML, CSS, JavaScript, and probably some sort of front-end framework like Angular or React. I definitely cannot say that front-end development is simple, but it is very visual, and I haven't experienced a lot of math involved with front-end development. The only time that I've run into any sort of math in front-end development is for writing media queries and responsive web design. And basically what this means is when you go from a desktop device to a mobile device, the components on the page are going to display differently. So you may have to resize them based on the screen that you're displaying them on, and with that comes some basic back-of-the-envelope calculations, basically the percentages that are taken up on the screen, calculating simple pixels, stuff like that. But beyond that, I haven't experienced a ton of math within front-end development, and therefore I would say that math is really not a requirement at all for a front-end developer. So if you're not strong in math, but you really like, deciding how things are going to be arranged in a defined space, being able to visualize things, getting into the mind of an end user and seeing how they might interact with your app, then front-end development is going to be really good for you. But I would say just be careful, don't make the mistake of thinking that all front-end developers are bad at math, because that is very far from the truth. You'll find plenty of front-end devs that are really strong in math and who just like the experience of developing the web and developing that user experience. Now let's jump to back-end development. Back-end development is a little bit different than front-end because you could use a variety of languages. A back-end dev could use anything from Python to Java to JavaScript, Ruby, stuff like that. All of these languages are valid server-side programming languages, and the goal of the back-end developer is to take the data that's in the database. This is stuff that's related to the user. It might be user details, it might be things that the user interacts with within your app. So say you're programming Instagram or something like that, there's photos that are related to a user, and there's posts that contain those photos. Those are all going to be stored in some sort of database, and therefore the front-end developer that we just talked about has to have a way to retrieve that information from a database and display it to the user. The back-end dev is the one that's responsible for providing a structured way, aka an API, for that front-end dev to consume the data that's sitting in that database. So is math required for this? Well, I think with back-end development, it is highly dependent on what you are trying to create. So say you're trying to create something like Instagram, especially in the early stages where things like image compression are really not that big of a deal. That only kind of comes in a little bit down the road when you become a very mature company. You've got millions of users that are storing their photos. But if you're starting out and you're just trying to make a proof of concept, as a back-end developer, you're not going to use pretty much any math when you're trying to create something like Instagram. Now, if you're trying to create a financial budgeting app for a general consumer, then you probably are going to need some math. Because when you're creating a budgeting app, you're creating a bunch of calculations and aggregations, basically displaying financial metrics to your user, and the entire app is based on numbers. Therefore, you're probably going to be writing at least a little bit of math within your code. That said, I don't think that you would be using anything more than, basic algebra, unless you're trying to, write some loan amortization calculator, to figure out what that person's mortgage payments are. Now moving on to machine learning, artificial intelligence, and data science. These three I group together because they're all kind of under the same umbrella. And this is where it gets a little bit interesting with the concept of math, because these disciplines definitely rely on math heavily, and you're going to be exposed to some sort of algorithms while you're working in these fields. If you don't know much about these, AI and machine learning and data science is really just about taking huge amounts of data and either distilling those down into useful insights in data science, or if you're working on, AI and machine learning, you're taking those huge data sets and you're using those data sets to train a robot or a computer. So basically, these disciplines rely on huge amounts of data and therefore rely on a lot of different algorithms that help you sort through and make sense of that data. Where this gets interesting is, how the math is actually applied within the discipline. Because you might think that you're going to be writing a bunch of code, bunch of algorithms and formulas, and you've got just this big long list of math in your code terminal. But that is usually not the case. In many cases, there are libraries, which are basically just sets of predefined functions that you can use to get these algorithms just pre-built. So Python has a very popular library called sklearn, which is, we'll call it a machine learning library that comes with a bunch of machine learning algorithms. And when you're writing that Python code, you don't actually have to write out all the formulas, and you don't even have to know what those formulas are. You just have to understand what the formulas do and how to implement them within the Python language. Let's take a simple example, linear regression. You probably covered this if you took any sort of math or statistics, and it's basically the formula that you put on a graph and see the correlation between two variables. So the formula is something like y equals mx plus b, where m is the slope and b is the y-intercept. And then the two variables, you got the dependent variable y and the independent variable x. So it's a pretty simple formula, and within Python's sklearn library, there is a pre-built function that you can use to calculate the linear regression of two variables. And this is the point I'm trying to make. Within these lines of code, you don't actually see a whole lot of math going on. But behind the scenes, within that library, there is a ton of math going on. Well, maybe not for linear regression, but especially for some of the more complex machine learning algorithms. So do you need math in order to become one of these types of programmers? Well, the answer is, I guess technically no, because you're not writing a ton of math within the code itself. But I would say that, if you didn't like math, if it was a huge struggle for you, then this is not going to be a good discipline to practice. Machine learning, AI, and data science, you pretty much work with math and statistics every day, and it's going to be a very painful and unenjoyable experience if math was not your strong suit and you didn't enjoy it. All right, let's move on to DevOps, or developer operations. A DevOps engineer is basically going to take a completed application and deploy it to the web. And what I mean by that is configuring all of the server functions to basically take the static code, just a big package of code, and serve that on the web so that users can access it and use it. Well, I'm definitely not an expert in DevOps. I haven't professionally been specifically a DevOps engineer. The only thing I can think of in terms of math that comes along with DevOps is looking at your expense dashboard and figuring out how much all of your different, server or, cloud-based components are costing your organization. In summary, I don't think that DevOps is a math-heavy field, and I think that without any sort of math, you can be successful as a DevOps engineer. And finally, a quality assurance, or QA/testing engineer. What this engineer is doing is basically taking that, deployed web app, or even maybe more in local development, and looking at the app, making sure that everything has been tested, all of the edge cases are worked out, and making sure that the user is experiencing the same thing that the developers had intended. Like backend development, this one is very dependent on what you are building. If you're trying to test a budgeting application, then yes, you're going to have to write some math into your code and make sure that everything is being calculated correctly. But if you're doing something like Instagram and testing that, you're probably not going to be writing a whole lot of math within your test. Now that we've covered a various amount of disciplines within software engineering, let's talk about whether math gives you an advantage as a general software engineer. If you haven't been on it yet, there's a site called Stack Overflow, which is a very popular place for developers to get a lot of their programming questions answered and figure out bugs within their code. Stack Overflow has a lot of users, and they do an annual survey for developers to just get a better idea of what these developers do, where they come from, all that kind of stuff. In 2020, they surveyed, about 45,000 developers, and it came out that only about 3.5% or 4% of those developers surveyed had a degree in math or statistics. While this certainly doesn't prove anything, it's interesting to look at and just get an idea of what backgrounds programmers come from. And with my personal experience, I can definitely say that in almost all cases, except for maybe if you're looking into machine learning and that kind of stuff, anything above basic algebra is not really going to directly apply to your programming capabilities. My personal experience has been this. In math, you learn a set of concepts. You learn a lot of techniques and stuff. But I think we need to separate those techniques that you're learning from the skills you're acquiring while you're learning them. And I think that those skills, the problem-solving skills that we talked about, do translate over to programming directly and give you a bit of an advantage. But the techniques that you're learning, say solving an integral problem within calculus, you're never going to use integrals as a programmer unless you have a very specific use case for them. So in conclusion, I think that it is it's not math that gives you an advantage in programming, but it's the thought process behind, solving math problems that will help you out in programming. I like to think about this in terms of an analogy. So let's look at the difference between running and cycling. Now, these two sports are both endurance sports, which means that they require a good cardiovascular fitness within the person doing them. Now, they also touch very different muscle groups within the body. They're going to hit different muscles within your legs. But if you ask two different people, one person who does a lot of running and one person who doesn't exercise at all, to enter a 20-mile bike race tomorrow, who do you think is going to do better? Well, obviously the runner who's in good cardiovascular condition is probably going to fare better in this bike race. All I'm saying with the math and programming thing is that if you come from a math background or something similar that flexes your problem-solving muscle very often, then you're going to be a lot better off when you start to learn programming than someone who might have come from a social science or someone who has worked in a field that does not require you to flex that muscle and to sit down and really focus on one problem for extended periods of time. So again, I think the conclusion is it's not math itself, but the process behind solving math problems that is going to help you out as a programmer and is going to give you that leg up. But the final question that we must answer is the one that you're probably here for in the first place. And that is, am I good enough? Am I fit to be a programmer? Am I someone who's going to excel in this? Obviously, you're not going to make a commitment to learn something that you know from the start you're not going to be good at. But all I'll say is that if you're wondering whether your maybe not so strong math skills are going to dictate your success in the field of software engineering, I would say keep pushing forward and keep trying to learn how to code. There are going to be disciplines somewhere within software engineering as a broader discipline that you're going to be good at, whether that's front-end development or some sort of specialization in something that I haven't mentioned. There's definitely something out there for you that is not going to require you to be excellent in math. Therefore, I want to use these last few seconds to encourage you to keep moving forward, keep pushing along, and try to learn this skill of software engineering and computer programming, because the rewards you'll receive, on the other side are far greater than the pain you're experiencing right now of trying to decide whether it's right for you or just trying to learn it in general. And that's it. Before you leave, make sure to hit the subscribe button and like this video, and I will see you next time.